of things before I start. You got to make sure on your calculator that under apps, you have a Poly Simulator. You'll need this for 3.3. So under your apps on your calculator, make sure that you have a Poly Simulator underneath your apps. You'll see it, I think. Most graphing calculators have them. Another thing is the homework. I changed it. It's 1, 3, 5, 6, 8, and 9, 11, 18, 11, 17, 18, 19, 27, and 29. So I changed it as of this last year. I switched it. So there are two definitions of a derivative. The one derivative is the one you know, f of a plus h minus f of a all over h as h approaches 0. The only difference in this chapter is they changed the x to an a, but it's the same formula. And the other formula is the alternative definition of a derivative. It's the limit as x approaches a, f of x minus f of a all over x minus a. And you're going to see where and why you would use two different formulas. And I'll show you that you can solve them both ways, but the alternative way might be faster than the regular way that you learned. So here we go. Example using both definitions. So we're going to find the derivative, the old-fashioned way that we learned in the last chapter. Like I said, the only difference is I changed the x's to the a. So in place of all the x's, we are going to put a plus h squared minus a squared all over h. So the limit as h approaches 0 of a squared plus 2ah's plus h squared minus a squared all over h. The a squares cancel out. And if you remember from the last chapter, you know you're doing it right if all your terms only have h, and now you can take an h out of all three of them, and you're going to get 2a plus h. And as h approaches 0, your formula for the derivative is 2a or 2x. And you're supposed to check it at x equals 1 or a equals 1, so the derivative is 2. And where we got the 2 from, or that is right up here, x equals 1, x is equal to a is what I told you. So here's the alternative one that you've never used before. The limit as x approaches a of f of x minus f of a all over x minus a. This is the alternative. So here's f of x. You're going to put f of x up on top. That's x squared minus, you're going to put in place of x a, so it's a squared all over x minus a. You can't put in place of x the a, because what happens if you plug the x in for a? What are you going to get in the denominator? You would get 0. That's why you have to leave it as x minus a. This is the limit as x approaches a of x minus a all over x plus a all over x minus a. I factored the numerator. Those two cancel out. And now, since both of them, I can, as x approaches a, so that means I'm going to replace the x with an a, which makes it equal to 2a, and a is equal to 1, which is equal to 2. Two different ways of doing it, but same answers. Okay, the next page. This is the notation way of writing derivatives for the rest of the year. Newton's way, y equals x to the second. Newton's way would be a little y with a little slash up above, which means prime, which means first derivative. And the first derivative of x squared, we just did it, was 2a or 2x. Leibniz way is not Newton's way. He has y equals x squared, but instead of using y prime, he says the derivative of y with respect to x, dy dx, which also means derivative, and the derivative of y equals x squared is 2x. I want to give you some other ones. This y double slashes means the double derivative, and the double derivative of that is 2, but I'll show you how we got it. The double derivative for this one would be 2 squared y over dx squared. That's the double derivative of Leibniz way of doing it, and that would also be 2. So those are just different ways of writing a derivative. When they ask you to find the derivative, really look for these little dashes, or the dy dx, or the d squared y over dx squared. They all mean derivative. Before I leave, again, the derivative, what's the derivative? It's the formula to find the slope of the tangent line. So instead of saying, I'm going to find the formula to find the slope of the tangent line, I'm just going to say derivative. So one word instead of 1, 2, 3, 4, 5, 6, 7, 8, 9 words, I just said derivative. Okay, one-sided derivatives, you had this in chapter 2. Now we're going to get a little bit more involved. So we're going to look at this and determine whether the graph has a tangent at x equals 0. Decide if it has a tangent, slope of the tangent line, at x equals 0. So basically, I'm going to find the derivative for this one, and I'm just going to use the limit as h approaches 0 of x plus h squared minus x squared all over h, the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. We just did this one on the last page, so I'm just kind of going a little bit faster. If I take out the h's, I'm going to have 2x plus h. Now I can finally plug 0 in, and I get 2x, and you're looking at x equals 0, which ends up being 0 for the slope for this one. And now I have to do the other one, because they both have 0. They both have 0, so I need to find that one, and I'm going to do the same thing. I'll give you the formula quick here. So in place of x, I'm going to put 2 parentheses 8 plus h minus 2a all over h. This is the limit as h approaches 0 of 2a plus 2h minus 2a all over h. The 2a and the negative 2a cancel out. H goes into h 2 times. You just get 2. You can't plug the 0 in because you don't even have an h to plug in. But they have 2 different derivatives. So they have one-sided derivatives. This one has a derivative of 0, and this one has a derivative of 2. There are 2 separate, so there is no derivative at x equals 0, because you had 2 different slopes at x equals 0. You should always check before you check your derivatives if it's even continuous. at x equals 0. And yes, it is continuous because they both equal 0 at x equals 0, so. Okay, the next one. The alternative derivative is way easier to use to find the derivative for this one than the old one. So I'm going to do the alternative one for this one. It's f of x minus f of a all over x minus a. So the limit as x approaches a of f of x, which is the square root of x, minus the square root of a all over x minus a. The limit as x approaches a, this is the square root of x minus the square root of a, and this can be factored into the square root of x minus the square root of a times the square root of x minus the square plus the square root of a. These two cancel out, so you have 1 over the square root of x over the square root of a. I couldn't plug it in here because it would have been equal to 0, but now I can plug x approaches a. In place of x, I can put a, and I'm going to get 1 over 2 root a. So that's called the derivative of this problem. And they want you to specifically find the derivative at x equals 4. So it's going to equal 1 over 2 root 4, which ends up being 1/4 is the derivative. So radicals are easier if you use the alternative. I would say fractions are easier. You guys remember doing the fraction before. So the limit, I'm just going to show you the old way of doing it. It would have been 1 over a plus h minus 1 over a all over h. And if you remember doing this in chapter 2, you had to find a common denominator and do all that. But instead, I'm going to use the other one as x approaches a of 1 over x minus 1 over a all over x minus a. So this is the limit as x approaches a. The common denominator on the top is ax. You're going to have an a here and an x here all over x minus a, which gives you a minus x all over ax all over x minus a. So I put this all together using only one common denominator. And then this is the limit as x approaches a. I have to keep doing it because if I put that into there, it would still make 0. So I know I have to keep going. A minus x all over ax times 1 over x minus a. The limit as x approaches a. These two I can cancel out, but they're opposites of each other, so it's a negative 1 over ax, which is the limit as x approaches a is going to be, I don't have to do this anymore because I can put this in there and get the negative 1 over a squared is the formula for this one. And as x approaches 3, or when x is equal to 3, I mean, is a negative 1/9. So sometimes the alternative way is easier than, so I would use this one when it's a polynomial. I would use the alternative one when it's a fraction, or if it's a square root, or a little bit more difficult one, I would use the alternative. Okay, part 6. If f of 3 equals 4 and f prime of 3 equals 2, then find the tangent line at x equals 3 and find the normal line at x equals 3. So this was a question on the ACTs, and you have to know how to decipher all of this in part 6. So when they say if f of 3 equals 4, you are thinking to yourself that is just the point 3 comma 4. Remember that functions write it as f of 3 equals 4, but it's really the point 3 comma 4. And when they say f prime of 3 equals 2, what this means is that the derivative at x equals 3 is 2. The slope, the derivative, the slope of the tangent line is 2. That's what that means. So, find the tangent line at x equals 3. The tangent line, remember, you're going to do y minus 4 equals something x minus 3. Remember, we keep using whenever they ask for the tangent line. In the normal line, they're going to do y minus 4 equals something x minus 3. And we got the 3 and the 4 because this is the point 3, 4. Well, it says the derivative at 3 is equal to 2. That means that the slope is equal to 2. So the normal line, the slope is equal to 2, but the normal line is a negative 1/2. Needs to go right there. And in simple form, it's y equals 2x minus 2, and in this one it's y equals a negative 1/2 x plus 5.5. So you really have to know what all of this stands for in this book. Okay, the next part, you found out, you could figure out to find f of x to f prime of x using equation, but how do you do it using a chart? So you got to watch very carefully. So what you're going to do is you're going to do the midpoints, and that's why this is a chart, the number of people in a room and the probability, and they want you to figure out the derivative. So what you have to do is between 0 and 5, what's halfway between 0 and 5? 2.5. It's called the midpoint. Between 5 and 10 is 7.5. 10 and 15 is 12.5, and so on. Okay, now we need to figure out the derivative. And how do you find out the derivative? Well, if this was the point, 0, 0, and 0.027, all you do is you find the slope at, here's 0, 0, and 5 over here. All you do is, if you find the midpoint between those two, that'll give you a pretty good guess at what the slope is. So all you're going to do is y, 0.27, minus y over x minus x, and you're going to get 0.0054. And then you're going to do it again. I'm going to erase this. Between 5 and 10, the halfway marker between 5 and 10 is 7.5. So I need to do 0.117 minus 0.027 divided by 10 minus 5 is equal to 0.0180. And then you keep doing it. This is how you find the derivative. You learned how to find the derivative using f of x plus h minus f of x all of h. This is how you find the derivative looking at a chart. So between 10 and 15 is right here. 12.5 would lie right in between 10 and 15. So you would have to do 0.253 minus 0.117 divided by 15 take away 10, which is equal to 0.0272. So that's how you find the derivative if giving a chart, and you'll need to know how to do this for the for the AP test and in this section. Okay, graphing f of x from f prime of x. How do you graph f of x from f prime of x? So this is where it gets a little bit more confusing. You have never seen a graph before. This is not a regular graph. This is an f prime of x graph. This is not a regular graph. This is a derivative graph. f prime of x is shown, which is the derivative graph. And the original one that we're gonna draw says that the original one goes through 0, 0. And f of x is continuous at all x's, okay? Okay, so basically, when you're doing this here and here and here and here and here and here, so basically, I'm gonna just f prime of 1. The slope at 1 is 2. F prime of 2, the slope at 2 is also 2. The slope at 3 is also 2, and so on. The slope at a -1, which is right here, is a -1. The slope at a -2 is a -1. So what does that look like? So, here's 1, 2, 3, 1, 2, 3. At f of a -1 and f of -2, it needs to have a slope of a -1. So it needs to go here, and then goes here, and go here. And connect your dots. And then this one needs to go, has a slope of 2, so it needs to go up 2 and over 1, up 2 and over 1. It looks like this. This is f of x. This is f of x, and that over there is the derivative graph. So, now I'm going to show you the opposite way of doing it. How do you graph f prime of x from f of x? Okay, so this is f of x, and this is f prime of x. What you're going to do to go this way is you're going to make little dashes. Let's use a different color. What you're going to do is put little dashes on your paper, like here, 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 just a bunch of, these are the slopes at all the different spots on the original graph. Okay, so what you're going to do is, this is the derivative graph, so I'm just going to put some slashes down. And you've never done this before, but you have to decide what these slopes are. Well, a horizontal line has a slope of 0, so I'm going to put a 0 up above those, because those are pretty easy. If you look at this one has a positive slope, this one has a positive slope, this one has a positive slope, this one has a positive, this one has a positive, this one has a positive, this one has a negative, this one has a negative, and this one has a negative. Okay, now you have to decide what type of a slope this is. I would say this one has a positive slope of 1. This one maybe would have a slope of a half. This one has a little bit steeper slope, so it's a positive 2. This one has a slope of about a 2. This one has a 3, and it's even steeper. This has a slope of 4. This one has about a -4. This one has about a -3 and a -2. When I mean that is, like, this is 0 slope. When I make one like that at a 45-degree angle, that has a slope of 1, up 1 and over 1. I mean, it looks about the same, up 1 and over 1. In this direction also, I would say this is a -1 slope. I would say, like, this one is more like a -1/3 of a slope. I would say this one is more of a 3 slope, of a positive slope. So it doesn't have to be perfectly, you're just trying to kind of estimate what the slopes look like. And over here, at 1, the slope is 0. So at 1, you have a slope of 0. At 2, you have a slope of about 1/2. At 2, you have a slope at about 1/2. Or maybe even a 1. This could be a 1 and that could be a 2, but at a -1, you have a slope of a -3. At a -2, you have a slope of 0, and at -3, you have a slope of 4. And if you connect your dots, this would be the derivative of f of x. Okay, let's do one more. Yep, there's one more on here, so let's do one more. This is to go from f of x to f prime of x. So to go from f of x to f prime of x, you are figuring out the slopes, and I always start with the flat ones first. And then I'm going to do this one, and I'm going to do this one, and this, and this, and this. So at 2, my slope is 0. At 4, my slope has a -2. At 4, my slope has a -2. At 5, my slope is 0. At 6 or 7, my slope is back up here at a positive. At 1, looks like a positive slope of 2. At 0, no, at -1, I mean, you have another, it's even steeper, and it's supposed to even be steeper. So it looks something like this. And then the last thing I'm going to show you is if you're given the derivative graph, the quickest way to come up with the regular graph. So this was the original one, on the other paper, if you remember. 1, 2, 3, and that's 1. So if you're going from the derivative to the original, this is the way I always do it. The part on the top, all of this is all positive slopes, and everything below it is a negative slopes. So at 0, 0, everything in this direction needs to be a positive slope, and everything in that direction needs to be a negative slope. So and it has to stay the same too. It can't change and it can't change. Let's do another one. F prime of x, and it looks something like that. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. That's the derivative graph. And you're trying to go back to the original. So I go like this. All of this is above the x-axis. All of these have positive slopes. And all of these also are above the x-axis. They have positive slopes. All of this part to here all have negative slopes, because remember, this is the derivative graph. And all of this also is a negative graph. So if it's positive slope, if you think about a positive slope, this part's going to be increasing. This part's going to be increasing. If you think of positive slopes, they increase. Negative slopes, they decrease. So from here to 0, you're going to increase. And we just don't know where to put it, but it's increasing. And then from 0 to 3, it's got to decrease. And then at 3 to 6, it's increasing again. And then from 6 to 7, it's going to decrease a little bit. And this is what the derivative would look like. And placing it on there, we'll talk about it later. So, but we also are going to be doing handouts trying to figure out how to go from derivative to regular and regular to derivative. So.